Ladies and gentlemen, allow me to introduce you to a topic of our
microphone or
I could do that.
the problem is possibly às vezes
Should I see
online.
Should I see it then?
Yes.
Okay.
It says that it's very good.
Okay then.
Вас лично.
Once again, ladies and gentlemen, allow me to introduce you to a topic of our research. And before we start, I will introduce the interesting problem in this research, and that's how to predict the outcome of eye surgery. Every surgery comes with a certain level of uncertainty, and also how to choose the right type of surgery for the right patients. Because if you talking, for example, about eye surgery, then one problem with the eye can be solved with different surgeries, and every surgery comes with its own advantages and disadvantages. So choosing the right surgery for the right patient is quite important. And this can be also done manually, but this process is very complex. It takes a lot of time, and it's also prone to human error. And because of this, we propose a solution to categorize the result of operation based on various factors for the individual patients, and we choose to do this by using a decision tree. And so we have a better understanding what a decision tree is. You can see this simple diagram. It is a hierarchic tree-like structure that consists of root node, branches, internal node, and leaf nodes. And to more about decision tree, it's a non-parametric supervised learning algorithm, which is used for classification task as well as for regression task. It's useful for data analysis. For example, regression trees are used to predict stock prices, and classification trees are used to label certain data into certain class. Probably the most famous example is classification of pictures, dogs and cats, and the image algorithms told us which picture is cat and which is dog. But medical professionals usually term in terms of classification, such as low risk and high risk, and because of this, we decide to use a classification tree in our research. And without going into too much details, the classification is a process of predicting a variable epsilon that takes value 1 to k, and based on a p predictors x1 to xp. And the goal is pretty much to find the value of epsilon based on the value of x. And tree structures in this situation can be quite beneficial because tree structure is adaptive to multiple variables and is also quite easy to visualize. But before we can build our tree, we first need to choose our invariant splitting criterion, and this refers to a criterion where tree is built based on the value of a single attribute, and there is also numerous approaches to select optimal variable. For example, info gain, Gini index, or gain ratio. Those are most prominent in this area. And for purpose of our work, we choose a Gini index. And now just quick description of project, we implemented R3 in programming language Python. Only third-party libraries we use were NumPy for mathematical operation and pandas for data manipulation. As I mentioned, as a splitting criterion, we choose Gini index, and data for this research were provided by a private eye center in Žilina. It contains records of 86 patients and 156 different eye surgeries. Some patients had both eyes operated, some only one, but for the purpose of this research, we consider every surgery as an individual. And the measured factor were diopter cylinders axis, but also some information about the clinical procedures, for example, use lenses, type of operations, and so on. And before we could start experimenting, first we need to split our data into several classes. We did splitting based on patient vision, based on improvement in patient visions, and the values were based on Snellen chart, which takes values from 0 to 1. You can also see the example of Snellen chart on the picture. 0 means that the patient couldn't read even the biggest letters, and 1 means he could read all the letters. And sex parameters is represented as a number, 1 or 0, and we also choose maximum depth of R3 to 3. So it's relatively simple and easy to read. And in the first experiment, we just took the data for all the patients and pretty much see what happens. And as you can see, the visual accuracy before operation was quite important, because patients with relatively good visions before operation don't have such a big room for improvement. And because of this, in our next experiment, we choose only patient with value of vision accuracy less or equal to 0.5. There were 119 such patients. And as you can see, the variable visual accuracy is still relatively important, but not as much as it was in previous experiment. In third experiment, we added an additional variable type of surgery that was either cataract surgery or refractive surgery, and we also represented this value as a number, either 1 or 0. But we very quickly discovered that this value has pretty much no effect on our decision tree, even if we increase the depth of it. But before we say that this variable had no effect on result of the surgery, we decided to split the data into 2 groups based on type of surgery. And as you can see, for the individual type of surgery, 2 different trees were built, and also different factors are important in individual trees. So it's so the type of operation have quite a large effect on the outcome of the operation. And we also conducted some additional experiments, which we tried to also add factors of type of lens, which were used in operation. But once again, we had a very similar result as in the first experiment. And after a closer examination of the data, we discovered that the majority of the lenses were of single type, more than 19%. And we encountered the same problem when we added another factor. flex or femtosecond catograph surgery, because we have only 4 instances in our data where this type of surgery was used, and that's simply not enough for any reasonable data analysis. And in conclusion, we show the possibility of using decision tree to predict the outcome of the surgery. So this could be used for healthcare provider to improve their ability and provide a better services for patients. But most importantly, we shows how important it is to gradually collect data, and not only for other researchers, but only for other medical institutions. And that's be all. If you have any question, you can ask them.
Thank you. Some questions? Yes.
Yes. Thank you for your presentation. My question is, it is a decision support making system. Yes. This your project can be
Start of study.
start of study, research plus some development. What about your planning certification of this program? And it's needed according to this future certification and get us for practical.
I answer. For this first analysis, we are preparing starting this study, and if it's better after this surgery and making this implant, it's better vision, then we continue creating a system which can add some patients' data, and the result of the system maybe is value, or maybe some percentage, say, if this surgery is helping, or and this is a mix of this is our first concept.
And then the second question related to what about privacy protection? This case, because you use
Yes.
real data.
These are real data, but firstly it's anonymized from our doctors in the team, and this anonymized data is backward added to patient in ambulance.
Thank you.